This is Chapter 4, Lesson 7, Linear and Nonlinear Functions. So in previous lessons, you learned that linear functions have graphs that are straight lines. This is because the rate of change between any two data points is a constant. Blank blank are functions whose rate of change are not constant. So in those two blanks, you're going to write non-linear functions. Okay? Therefore, their graphs are not straight lines. So let's take a look at some examples. So example number 1 says determine whether each table represents a linear or non-linear function and then explain. So if I look at my rates of change, my x's are going up by 2 each time and my y's are going down by 15 each time. So as x increases by 2, y decreases by 15. The rate of change is constant, so this function is linear. Okay, so notice the same amount each time. Number 2 gives me a table. The x's are going up by 3. The y's go up by 15, then 33, then 51. So as x increases by 3, y increases by a greater amount each time. So the rate of change is not constant, so it's non-linear. Okay, let's look at number 3. Number 3 says use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function of its age in weeks. Okay, so I can use the table to find the rates of change. So for 1,000 minus 825, I get 175. 1,185 minus 1,000 is 185. And I get 135 and then 100. The rates of change are not the same. Therefore, the function is nonlinear. Okay, you can always check on a graph to verify that they're not in a straight line. Okay. Number 4 says a square has a side length of s inches. The area of the square is a function of the side length. Does this situation represent a linear or nonlinear function? Explain. So I can make a table to show the areas of the square for the side lengths of 1, 2, 3, 4, and 5 inches. So for 1 squared is 1, 2 squared is 4, 9, 4 is 16, and 5 is 25. So here I'm going up by 1 each time. Here I go up by 3, then I go up by 5, then I go up by 7, then I go up by 9. So that is not a constant rate, so that means that it's not a straight line, so therefore it is not linear. Okay. You can also look at the graph and see that the graph is not a straight line, so it is a nonlinear function. Okay. On the next page, there are a couple of try-it problems. Go ahead, pause the video. When you are done, we will go over the try-it problems together. Now that you've had a chance to look at the try-it problems, let's go over them together. Letter A says determine whether the table represents a linear or nonlinear function. Explain. So I can look at my table. The x values go up by 5 each time, and the y values decrease by 4 each time. So this is a linear function. The x increase by 5 and the y decreases by 4 each time. Okay. Letter B says determine whether the table represents a linear or nonlinear function. Explain. So my x increases by 2. So I go up 2, 2, plus 2 each time. My y decreases by 2, or goes up by 2, so plus 2 here. Then I do plus 6, then I do plus 10. So this is nonlinear. X increases by a constant rate, but Y does not. Okay, so again, don't forget you need to explain why it is a linear or nonlinear function. Don't forget that, okay? So letter C says tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Explain. So I can look at the table over here. So there, my X values go up by 1 each time. My Y value goes up by 5 each time. So this is a linear function. Because both X and Y have a constant rate of change. Okay. Letter D says a square has a side length of S inches. The perimeter of the square is a function of the side length. Does the situation represent a linear or a non-linear function? Explain. Okay. So let's say, let's make a table. So a square has a side length of S inches. The perimeter of the square is a function of the side length, right? So a square, remember I'm multiplying that by 4. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. Okay? 4 is 16, so on and so forth. So this goes up by 1 each time. And this, I add 4 each time. So this is a linear function because the side length and perimeter of a square have a constant rate of change. And that is the end of lesson 7.